Okay, everybody, this is 4.3. We're looking again at triangle congruencies, and we're going to add to our list. Last section, we started with um, two theorems that proved that triangles were congruent. One was side, side, side. The other one was side, angle, side, which meant that the two sides that were congruent in different triangles create an angle, and those angles are also going to be congruent between the two triangles. Okay, so we're going to add to this list. We're going to have two more, ASA and AAS. ASA is angle, side, angle, and AAS is angle, angle, side. So if I can prove these couple different things now with triangles, I can now just say, you know, the whole triangle is congruent to the other entire triangle. All right. So it's using pieces of triangles in a particular order, a particular way, that I can now make a proof that all of them are going to be equal. Okay. So let's keep going here. If you guys don't have to write postulate 4.3 or theorem 4.2, we can just go ahead and write down the definitions to the postulates and theorem. But you know, I'm always going to refer to them by their abbreviations here. Okay. So once you get those written down, I'm going to draw some pictures for you to kind of illustrate what they mean, because these ones are a little bit trickier than the first two that we learned. So if you want to hit pause, write this stuff down, and come on back and include then the drawings in your notes, so leave yourself a little room. Okay. Okay, so for angle, side, angle, it's saying that if two angles of a triangle are equal or congruent to corresponding angles of a second triangle, and the included side of those two triangles are equal, then the triangles are going to be congruent. Okay, so this one gets a little tricky. So let's go ahead. I drew those two. I'm going to show that this angle right here is equal to this angle right here, and this angle right here is equal to the corresponding angle over here. Okay. Now the included side, and you got to make some kind of things up for yourself to remember how this goes, but they got to be connected. So the included side means the side, and what I remember is the side between the two angles that are equal is congruent to the side between the two angles that are equal. Okay, so angle, side, angle. All right. Now, I gave you that drawing. That's just kind of a basic drawing, but it doesn't have to be just those two sides and the two angles from each triangle. Remember, that could be anywhere in the triangle. It doesn't have to be right there. So a lot of kids kind of get locked into that drawing, and it always has to be that way. And you could do those, you know, 3 or 4 different ways, really. Okay. So that's how to kind of illustrate that theorem. If I go ahead and do this second one, angle, angle, side, this one can get dicey for kids. Okay. Sorry, that's not really even close to being the same. Hold on. Okay, because this one really can get drawn a bunch of different ways. So you got that. This. Okay. So two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the triangles can be congruent. So, you know, if the word corresponding needs to be in there too, because this one we can play some serious games with you on these, so you got to really have this down. So what it says is, you know, let's say I'll take this angle and this angle are equal, and let's say I take this angle is equal to this angle. Okay. Now, kind of using the verbiage we used on the last one, we had the included side for angle, side, angle. Well, angle, angle, side is the non-included side. This gets dicey. Non-included to me was it's not between the two angles. So I've got kind of choices here. So let's just really pay attention. this side right here and this side right here are congruent, and they're not included between the angles. So I can prove this by angle, angle, side, okay? But there was really two sides that were not included. So this side right here could also be congruent to this side over here, and I can prove it by angle, angle, side using those two sides. So that one can get kind of, kind of weird. And I'll give you a really fast, you don't have to write this down, really fast one. I could say that this angle and this angle are equal, this angle and this angle are equal. And then I'm going to be really tricky. I'm going to say that this side is congruent to that side. Are the triangles congruent? They're not, because the two sides that I said were congruent are not corresponding, so therefore they can't be congruent. Okay, so that's kind of a trick. Just making sure you're paying attention to what the real rule is. Okay, so that last one can get kind of got to be really careful with those. Okay, so now we have 4 triangle congruencies that we can use to prove that triangles are congruent. And you just got to have these down, and you got to work towards them, and make sure that you can use some of those different things that we keep, using as keys. What can I use in a proof to be able to do this? Okay. So once you go ahead, once you write down what's given and what we have to prove here, go ahead and write down or draw the figure. See if I can move it. Guess I can't. I'm not. Now it shows up. Okay, just giving myself some room there. And if you go ahead and draw in your 2-column proof. And what did they give me? What do I have to prove? Okay, so. And once again, if I'm going too fast, stop the video and hit play when you get caught up, okay? All right, so once again, we're going to go ahead and we're going to draw. They're not doing it for us now. We're going to draw in what they gave me so I can see it. AD is parallel to CE or EC, okay? And BD is going to be congruent to BC. Okay, now I'm going to stop here for just a moment. There's things that we've talked about in the past and some other proofs that we've done. This figure that we got here, I hope you understand there's 2 triangles there, okay? And when they're put together like that, I either call them a bow tie or I call them an hourglass, just kind of how they're arranged, okay? Whenever I have a bow tie or hourglass, I'm always going to think vertical angles. Okay. Whenever I have parallel lines, okay, whenever I have parallel lines, I'm going to think of transversal. And typically with transversal, I'm going to use alternate interior angles. Okay. And it doesn't happen in this case, but I'll just kind of draw a really quick one. Remember, if you have a figure that's been cut by a diagonal, I'm going to use reflexive property. Okay, I think I need to move this over here. Hold on. Here a little bit. Sometimes I'm hearing that the right-hand side of the board is not easily seen when drawn on it. So there's 3 things here that I want you guys to use as keys. When I see this, I think this. Okay, so this transversal thing I didn't do so good. Okay, key and then the reflective. This goes there. Sorry. And then reflexive is its own thing. Okay, so there's 3 things here that if you just every time I see something that looks like this, I'm going to go bang, I can use this in a proof. Every time I see a figure like this, I can use that in a proof. If you got that down, if you can really remember these things, it makes this stuff so much easier. Okay, so let's get back to the proof. What do you see? I see a bow tie. What do you see when you have a bow tie? I got vertical angles. Okay, now I got to be careful here too. I'm going to show they're equal, but I can't just say angle B is equal to angle B. A lot of kids want to do that, and then they use reflexive. That's not what it is, and I have to use 3 letters. So I'm going to go A, B, D. Angle A, B, D is now congruent to angle, and I'm going to go E, B, C. Okay? Why can I say that? Because they're vertical angles. Okay? Easy. Make it easy. Okay? So I've done that. I've got an angle here that's equal to this one. I've got a side here that's equal to this. And I'll put a little cheat sheet up. I've got 4 of these that we've learned about now. And I'll just be honest with you guys. We want you to learn these last 2 because that's what we're doing. Okay? So I'm working towards that. So I need, in both of these, I need 2 angles that are equal. I only got 1. In both of them, I need one side that's equal. I only got 1. So I got some more work. But let's go back to the little keys I told you about. You've got parallel lines, and if I've got parallel lines, and therefore I have a transversal, and if I have a transversal, then I can use alternate interior angles. Now I got a mess going on here. I apologize for that. Let me kind of illustrate the transversal with dotted lines. Maybe I'll go here. Okay, and I really got, so those are my lines that are parallel. And I could really use any line here to get a transversal line. So let's go ahead and use this one. Okay. So I can use alternate interior angles here. So that's going to mean that this angle right here and this angle right here are alternate interior angles. Okay. So now, do I have 2 angles in each triangle that are equal? And yes, I do. I got this one equal, this one and this one are equal, so there's 2 angles. And now I've got this side and this side are congruent. So which one is it? Is it angle side angle, or is it angle angle side? Okay, let me, while you're thinking about that, I'm going to go. We got to write down the angles that are going to be equal here that we just did. So I'm going to go angle B, A, D is congruent to angle, I'm going to go B, E, C. And that was by alternate interior angles. Okay, we used that last section. Using it again. So now I can prove it, and hopefully you understood that the triangle ABD is congruent to triangle EBC. And the sides that were congruent were not included between the 2 angles. So that means it's A, S. Okay. Well, guys, maybe that proof was a little bit difficult for us, but this is just a learning process. It's tell me what you know, but some of the stuff we know came from a different chapter, and we just had to apply it to what we're doing now. Okay, but I want you to remember too, I said this last section, the last step is one of these triangle congruencies. That's what you're working towards. So know that I got to work towards that. Maybe that makes it equal. But these 3 keys, the 3 things I starred here, just if you got that down and you're looking for those all the time, it's going to make these so easy. Okay. All right. You go here. If you guys go ahead and draw this figure here, and they're giving you that, so include that, and then they're giving you this here. If you could draw this figure, and I'm trying to prove, are they congruent, and then by what? So over here, you're going to try to prove them by one of these 4. Okay. So these actually probably would have been nicer to do before the proof, but I didn't make this stuff up. Okay. So AR bisects angle CAT. So this is really important. First off, they gave me that these two sides are equal. And they tell me that this line right here is bisecting the angle that's down here. Okay, so I'm going to show, no, I'll get rid of that. I'm going to show this angle. Remember, bisect means cut something into equal halves. So there's angles that are congruent. Okay, now, since they gave me, you get it, this is how you need to start thinking. Since they gave me angles that are equal, I know it's probably not going to be that one, okay, because I need all three sides. I've got angles that are equal, so it's probably not going to be that, okay? What else do you know? So the keys I just wrote down a little while ago, do I have a line that's bisecting, or I'm sorry, not bisecting, but cutting a figure into two triangles? You do, and so AR is really congruent to AR by the reflexive property. And at this point, could I prove that the two triangles are congruent? And you can. Okay, you can go side, angle, side is congruent to side, angle, side. Okay, so S, A, S. Right? Okay, so you look at this figure, you know, remember that arrows here are showing that the lines are parallel to each other. So a couple things right off the bat you're going to be thinking of. First off, they got parallel lines. So hopefully you remembered my key last problem was transversals. And if you got transversals, I'm thinking alternate interior angles. Okay. The other thing too, it looks like once again I got either a rhombus or a parallelogram, but it's being cut by a diagonal, so that's telling me reflexive property that that side is equal to itself. Okay. Now what's going to happen here? It's just learning and understanding. Sides are equal here, but that's only one side of each triangle. Transversals up here dealt with alternate interior angles. Okay. So I'm probably, once again, not going to be using that one. I'm going to be using some angles. So here's, let's do this. We'll create that as my transversal line. I'll go ahead and draw. These lines are parallel. I got transversals all over the place here. Okay. So remember alternate interior angles. Well, guys, right here, this angle is an alternate interior angle with this guy. It's in between the lines. And remember, how many pairs of alternate interior angles do you have in a transversal? You should say 2 pairs. So this is another pair of alternate interior angles. They should be equal because the lines are parallel. Okay. So now look, I've got 2 triangles congruent to 2 triangles, and I've got a side that's congruent to another side. So I think I've got angle, side, angle here, okay? All right, angle, side, angle on this one. Oh, there's balloons here. I think they're supposed to pop them to see if they're congruent, yes or no, and by what. So this one, side, angle, side. That's what we got, okay? Fix this one a little bit. Okay. Let's see with this balloon. I'm not even remembering. And yes, angle, side, angle, so we were correct, okay? All right. Excellent job there. So, you know, really important that you get these 4 things down. Just comes from some studying time. And I would study every night just so you got it down, kind of remember some of the nuances. And remember those keys that I wrote down too. Okay, if you can go ahead and draw these 2 figures, and we're going to do the same thing. Are they congruent by one of those 4 things? Okay. Okay. So for C, now the other 2 problems up above and D, they tell me some stuff, and then C they don't tell me really anything except that these 2 sides are equal. So I'm kind of on my own here. You know, I got to kind of rely on what I'm supposed to know. I got it looks like a parallelogram for sure in this one, but it's got a diagonal through it. So that must mean that this diagonal is going to be equal to itself, and it's part of both triangles. Okay, so other than that, I have really nothing to play with. The issue would be that some kids might go, okay, I got two sides here that are equal, and two sides that are equal. Two sides here are equal, and the side's equal to itself. So I might go SAS because, hey, that angle's in between, okay? But how do I prove that they're equal? Just because the sides are equal doesn't mean that the angles are going to be equal, okay? I could use it if they're parallel, but there's nothing here about things being parallel either. So, and let me draw this little illustration, okay? I got, if I drew this angle here with those two sides, and then I drew this, you know, could I say that these are equal and those are equal? Are those angles equal? And they're not. So we got to be really careful with not making stuff up. That's what we do all the time. We make stuff up, and then, you know, it's not correct. Okay, so let's see. And no, I cannot, with a sad face on that one. Okay. All right, and D, let's go ahead and draw stuff again. AR bisects angle CAT again. Okay, so we're going to go here. And here, bisecting means that it cuts something in equal halves. Once again, hey, I got a kite here, and this AR is cutting it into two triangles, so AR must be equal to AR by reflection. Okay, and then what else do you know? Well, from here, I know that it said that this got bisected, but it's really not saying anything about this, and I cannot assume that it's bisecting that angle. And so if I look at this, I've got an angle and a side and a side. Okay, well, angle, side, and the side makes that. And we didn't learn anything that was ASS. The only thing that's ASS in geometry is the teacher, basically, right? So that one is not a rule that we can use in geometry, okay? So, and don't make stuff up. I see that on tests and quizzes all the time, ASS, because that's what I got. Well, that's not a rule. So don't make it up. Let's just see if I'm right. And that's a big fat no either. So just being careful here with what we got. Don't make stuff up, okay? All right, we're gonna go here. That'll be kind of the end of section 4.3. It was kind of short. Section 4.4 kind of goes with this a little bit more, kind of adds on to it. So make sure you get into your notes, make sure that you're doing your classwork that went with them, and you know, if you got questions, make sure you're getting a hold of me. Okay, thank you.